So here's our first example of using a memory diagram. So this example is meant to be very, very simple. There's no variables. All it's really doing for example number one is worry about function calls and how our stack right beside me here is going to handle that. Now, in this example, I'm also going to show you kind of the other things that are going on around me because it is going to get more complicated down the road. So let me do that now. So obviously I'm going to have my code right here, and it's always going to be set up that way here on my left-hand side, and the main's always going to be at the bottom. Then above my head here is going to be the output. Anytime we have some type of couts, once we reach it, then it'll be put in the output. But the important part is actually here to my left, and that's the identifier and the value stack. Here you're going to be able to watch how the computer is really storing the calls in the background, not just the calls, but the values or variables inside of each one of those calls as well. So this is, for right now, is going to be very simple, but it's going to get a lot more complicated in a little bit. So in my very simple example that we have right here, you know that we're going to start off with the main, and then we're going to complete the main from top to bottom, and then finish the rest of that application. Now, so first I'm going to highlight the main. That's what we're going to call, so we haven't reached everything else yet, but main gets put onto the stack. Now, we haven't put any variables in there yet because frankly, we haven't reached it yet, but in the example that we have, we don't have any variables as well. So we're going to continue from main and continue from top to bottom. So our next item up for bid is going to be F3. So you could tell this F3 is a call because of the parentheses behind it. You can also tell because frankly there should be something matching just above it unless you include it from C++ and it may not be there because you include it from another library. But anyway, so F3 has cout computer programmers are. So again, I'm doing F3 even though it's really small. I'm going to complete it from top to bottom one step at a time. But there's only one line in this, and that's like I just told you. So you notice the output's there. The other important part, though, is to notice what's behind me. So here's the main. We're not done with the main, so that's really important that it's there. F3 is going to be basically stacked on top of it because that's what has the focus of the computer. And then as soon as it's done, we'll remove it, and it'll go back down to main, who has a focus and who is running. Now, because F3 just had that one line, we're done. Now, in reality, this item right here with F3 would be taken off the stack, but I wanted to leave it there so you know that it was there, but in reality, we'll return that address and stuff like that, all that memory back to the computer in its heap. So, we're done with F3. We completed it from top to bottom. What's going to be next? We're about to do F1, which is right after the F3. So F1 rich, sounds great right about now. So that's going to be displayed above my head here, but you'll also notice that again, we have our position for F1 as well, because again, that's what's currently in the stack. That's a call that we need to handle and focus on until done. Well, as you can again see, F1 is going to be done pretty quickly, just with a cout rich. So that's going to die on the vine, as I usually say in my other classes, and that's all done. So what are we doing after that? Well, in F number 1, we're done here. So we keep going down to main. Notice main is still alive here. We're going to return 0. Then we're done with the program. As soon as we're done with the program, notice main also cancels itself out too because it's done. And everything gets returned back to memory and the heap memory for the computer.